Good day, students. My name is Olubara Marilyn Kende, and I'm going to be taking mathematics today on the topic angles between lines and triangles. Remember, in our last topic, we talked about angles. Looked at the different types of angles and angles between lines. But today, we are going to be specifically looking at angles between lines and triangles. All right, our lesson objectives. By the end of this lesson, you should be able to calculate the angles between crossing lines using angle properties at a point, adjacent angles on a straight line, and vertically opposite angles. Also, by the end of this lesson today, you should be able to calculate the angles between parallel lines and a transversal. By the end of the lesson, you will know what a transversal is, and you'll be able to use the properties of alternate angles and corresponding angles and allied angles to calculate angles between parallel lines. Okay, first of all, we're going to be looking at angles on a straight line and angles at a point. Number one, adjacent angles on a straight line. All right, this is line XOY, and if you look at it from this direction, we have angle XOZ. And if you look at it from this direction, we also have angle ZOY or angle YOZ. Now, if you look at this angle, these two angles I just drew out for us, you see that they have a common vertex. Remember from previous study, we said the points which the arms of an angle intersect is called a vertex. So these both angles intersect at this point O. They lie next to each other. And when we have two angles lying next to each other, they are called adjacent angles. They are adjacent to each other. Now read this. In the diagram above, XOY is on a straight line. XOZ and XOY have a common vertex, like I explained now. They have a common intersection point. Now, since angles XOY and YOZ lie next to each other, we say that they are adjacent to each other, meaning in essence that they are adjacent angles on a straight line. Okay, now that we've gotten that, the sum of angles on a straight line is 180 degrees. I hope you remember that. The sum of angles on a straight line is 180 degrees. That is the sum of this angle A and the sum of this angle B is 180 degrees. Therefore, we can say that the sum of adjacent angles on a straight line is also 180 degrees. I hope you understand. Since the sum of angles on a straight line, this is the straight line XOY, since the sum of angles on this straight line is 180 degrees, we can also imply or say that the sum of adjacent angles on a straight line is also 180 degrees. Now, number two, we are going to be looking at complementary angles. Complementary angles. If two angles add up to 90 degrees, they are said to be complementary. If two angles add up to 90 degrees, they are said to be complementary. When we say angles are complementary, we mean they complement or complete each other. Now, we have an activity here. We are given a diagram containing two angles, angle A and angle B, and we are asked to measure the angles labeled in these diagrams. Remember from our last topic, we're taught how to use our protractor to measure accurately different types of angles. So we're going to be putting that into practice now. We are going to be using our protractor to measure angle A and to measure angle B. Now, the B part says we should sum the angles. The measurement of the angles, we should sum it, we should add it together and get an answer. Now, when we place our protractor on angle A, our answer is 36 degrees. Okay? Angle A is 36 degrees. We remember how to read it. We are reading anti-clockwise now. 0, 10, 20, 30, okay, 40. If you look at it very well, we have 0, 10, 20, 30, 35. Now, this line is resting on the next inch, which is 36 degrees. All right. So angle A is 36 degrees, and when we also measure for B, we see that B is 54 degrees. Now when we sum it together, we're going to have 90 degrees. Therefore, these angles, angle A and B, are complementary. Why? Because they add up to 90 degrees. Now, very quickly, number 3, supplementary angles. Supplementary angles. If the sum of two angles add up to 180 degrees, they are said to be supplementary. Also, adjacent angles on a straight line are said to be supplementary. So supplementary angles are just those angles that when you take their sum, we have 180 degrees. Remember, we said adjacent angles on straight line sums up to 180 degrees. Therefore, an adjacent angles on a straight line are also supplementary angles. Okay, we have another activity here. We are asked to measure the angles in this diagram: angle Y, angle X, and angle Z. Now, when we measure it, we're asked to sum it and get our answer. Now, when we do that, we discover that X is 48 degrees, Y is 69 degrees, and Z is 63 degrees. Now, when we take the sum of all these angles, we are going to get 180 degrees. So, in essence, these angles X, Y, and Z are supplementary angles because they add up to 180 degrees. I hope you're understanding what I am teaching. Okay, number 4, we have angles at a point. Angles at a point. Now, the sum of the angles at a point is 360 degrees. Now, look at this diagram here. This is a point. Okay, remember we said the point of intersection where the arms of an angle meets is called a vertex. All right, now this is a vertex point and it is labeled O. Now, in this diagram below, all the lines have intersected at this point, and we are asked to measure angle A, angle B, angle C, and angle D. Now, when we use our protractor to measure these angles individually, we have A as 50 degrees, B as 120 degrees, C as 130 degrees, and D as 60 degrees. Now, when you take the sum, when you add all these angles together, we're going to get 360 degrees. So, in essence, the sum of angles at a point, the sum of all these angles A, B, C, and D is 360, meaning it is an angle. They are all angles at a point. All right, number 5, vertically opposite angles. Vertically opposite angles. Now, look at this diagram very well. If you look at it, you discover that A and B are opposite to each other. They are vertically opposite to each other. Now, same thing with X and Y. Okay, they are vertically opposite to each other. Now, let's read. When two straight lines intersect as shown in this figure, okay, when they intersect as shown in this figure, then vertically opposite angles are equal. Okay, angle X and Y are vertically opposite angles. Likewise, angle A and B are vertically opposite angles. These type of angles are also called the X angles. Okay, so you can easily recognize them as vertically opposite. Whenever you see the X angles, know that they are vertically opposite angles. All right, now when the angles in this diagram are measured, when we have angle X measured and when we have angle Y measured, we discover that they are equal. All right, they are the same. We have X as 112 degrees. We also have Y as 112 degrees. We have A as 68 degrees. And we also have B as 68 degrees. Therefore, vertically opposite angles are equal. Now, number 6, angles in parallel lines. Okay, we're going to be looking at angles in parallel lines. Now, parallel lines from previous study are those lines that never meet. They have the same direction, the same distance, but they do not have an intersection point. They do not meet. So they have the same direction as shown by these arrows. You can see they are going in the same direction. They are facing the same direction. They have the same distance, okay, but they do not intersect. They do not meet. Now, when two lines are crossed by a transversal, okay, now this is a transversal, okay? When a straight line is drawn across two parallel lines, we have a transversal. When a transversal is cut across two parallel lines, two sets of angles are formed. Okay, we have alternate angles and corresponding angles. Now take note of this. This is a transversal cutting between two parallel lines. Now let's look at the different types of angles formed when a transversal cuts across two parallel lines. Okay, alternate angles. Remember, we just said when a transversal cuts across two parallel lines, we have two types of angles formed. The first one is an alternate angle. Now, alternate angles are equal. Okay, when we measure these angles A and B with a protractor, we discover that they are the same. Okay, same with X and Y. When we measure X, we discover that the value for X is also the value for Y. All right, so in essence, alternate angles are equal. All right, angles X and Y are alternate, so as angle A and B. Therefore, when a transversal cuts parallel lines, alternate angles formed are equal. Okay, alternate angles have a Z-like structure. Okay, like letter Z. So you can easily recognize them using the letter Z. Number 8, corresponding angles. Now, corresponding angles also are equal. Now, look at these corresponding angles. There's a transversal here cutting between two parallel lines. We have angle Y and angle X. We have angle Q and angle P. Now, when you take the measurement of angle X, you discover that it's equal and it's the same with angle Y. So, in essence, corresponding angles are equal. Angle X is equal to angle Y. You see, when we measured angle X, we have 115 degrees. And when we also measure Y, we have 115 degrees. So, in essence, they are equal. Same goes for angle Q and angle P. Now, when a transversal line cuts through parallel lines, corresponding angles are formed. Remember, we said when a transversal line cuts through two parallel lines, two sets of angles are formed. We have alternate and corresponding. So this is the corresponding angles. Now, the corresponding angles can be easily recognized by looking for the F-shaped angles. Now, take a very close look at this and follow my pointer. You can see that there is a sort of F-looking structure in this diagram. So if you want to recognize a corresponding angle, you can easily recognize it by looking for the F-shaped angles. All right, co-interior angles or allied angles. Now, co-interior angles are supplementary angles because they add up to 180 degrees. Remember, we said supplementary angles are those angles that when we take their sum, we have a total of 180 degrees. So, co-interior angles are types of supplementary angles because they add up to 180 degrees. Now, co-interior angles can also be known as allied angles. Now, look at this. This is a co-interior angle. We have angle Y and angle X. We have angle A and angle B. Okay. Now, when you take the measurement for angle X and take the measurement for angle Y, we discover that they are the same. When we take the measurement for angle X and we take the measurement for angle Y, we discover that the sum will give us 180 degrees. Similarly, when we take the measurement for angle A and angle B, we realize that the sum will give us 180 degrees. So these angles are called co-interior angles or supplementary angles, or they are also called allied angles. Now, the co-interior angles can be easily recognized by looking for the C shape. Okay, now I want you to follow my pointer and look very closely. You can see a kind of C shape or a U shape. Okay, now let me give you some tips to recognizing co-interior angles. Now, if you want to know co-interior angles, just look for the angles within the frame of the arms of the angle. Okay, I hope you understand. If you look at it, you will see that the angles are inside, they are in the interior of this shape. So the co-interior angle or allied angles look like a letter C or U. They are the angles inside a C structure or a U structure type of angles. Okay, I hope you understand that. Now, I want us to take note that sometimes we can have a corresponding angle or an alternate angle when a transversal crosses a pair of non-parallel lines. Okay, now I want us to reflect back on how we said we can form an alternate or corresponding angle. We said an alternate or corresponding angle can be formed when a transversal crosses between pair of parallel lines. Okay, and we said that the alternate angles formed or the corresponding angles formed are always equal. Now look at this. They said when a transversal crosses a pair of non-parallel lines, we can get alternate or corresponding angles. Now look at these diagrams. Line GH is not going the same direction with line EF. No, we said parallel lines have the same direction, the same distance. Okay, but they never meet. Their lines that never meet. But look at this very closely. You would see that line GH is not going in the same direction with line EF. Alright, and they definitely do not have the same distances. Now look at this. Line CD and line AB are going in totally different directions. Okay, and they do not have equal distances. And a transversal is cutting across these non-parallel lines. Okay, when a transversal cuts across these non-parallel lines, alternate angles can also be formed. But the difference is that the alternate angles formed here, they are not equal. I hope you understand. The alternate angle formed when a transversal crosses between pairs of non-parallel lines are not equal. Now, line GH is not parallel to EF, and line CD is not parallel to line AB. Okay? In this case, the alternate angles formed are not equal. Therefore, X is not equal to Y. Okay? X is not equal to Y, and angle M is not equal to N. Now, let's look at some evaluations. Number 1, state whether the following pairs of angles are complementary or supplementary. Okay, A, B, C, D, A, B, and C. We are asked to state whether these angles are complementary or supplementary. 2, find the angles marked with letters in the following figures and state your reasons for the solution. Very important. You find the angle marked with the letter. Okay, find the angle marked with the letters and you state your reason for the solution. Very important. You have to state your reason for the solution. Number 3, you have to find the angles marked with letters in the following diagrams and state your reason also for the solution. Now you have to find the angles marked with letters here, X, Y, Z, X, R, T. You have to find them and state your reason. Number 4 says find the angles marked with letters also in these figures. Alright, you find the angles marked with letters. Alright, you have to find the value of all these angles marked with letters and state your solution. Now, number 5 says calculate the value of the alphabet in the diagram shown below. Alright, you have to find these letters, find the angles represented by these letters. I'm going to give us a few minutes to do these evaluations. Now, solution. Number 1, we're asked, number 1A, we are given these angles and we're asked to state whether they are complementary or supplementary. Now, number 1A is a complementary angle. Why? Because if you add them together, you're going to get a sum of 90 degrees. I hope you remember that. And 2 is supplementary angles because when you take the sum of these two angles, we're going to get a total of 180 degrees. And same goes for C. All right. the angle at 60 degree and 120 degree is a supplementary angle for the same reason they add up to 180 degrees. Now, number 2, we're asked to find the value of x. We're asked to find the value of x. Now, if you look at this diagram very well, it is at right angle, okay? And we know that angles that add up to 90 are complementary angles. So we're just going to subtract 27 from 90, all right? We'll subtract 27 from 90 and we'll get 63 degrees. Now, if we have to state the reason for this solution, the reason is that angles that add up to 90 degrees are complementary. Now, in this, we're asked to find the value of x, all right? We're asked to find the value of x. Now, to do that, the sum of angles on a straight line. This is a straight line. All these angles are on this straight line. The sum of angles on a straight line, like we said, is 180 degrees. So very, very simply, we are going to just add all these angles together, all right? We'll add it together, we'll get this value, then we subtract from 180 degrees. The final answer is 33 degrees. Now, to cross-check if your answer is correct, you can impute the value into this angle, into x here, then you take the sum. If it gives you 180 degrees, you are correct. And if it doesn't, you are wrong. I hope you got that question correctly. Now, the C part says we should find the value of x and x in this diagram. Now, if you look very carefully, you see that all the angles are on a point. They have a single intersection point. They have a common vertex, meaning these are angles at a point. And from study, we've seen that the angles at a point is 360 degrees. So what we're going to do is we are going to subtract 360 from 320. We're going to subtract 320 from 360. All right. Now, when we get that, we're going to have 40 degrees. Now, if you look closely at this diagram, you will see that x and x are equal. All right. So we're just going to split our answer 40 into 2. All right. So we're going to divide it, and it's going to give us 20. So 20 is x. X is equal to 20. Now, to cross-check if your answer is correct, just impute x into this 20 and add to 320. If it gives you 360 degrees, you are correct, and please put your hands together for yourself. Now, the reason for this solution is that the sum of angles on a point is 360 degrees. Now, number 3, we're asked to find the value of x, y, and z in this diagram, okay? Now, remember that we said vertically opposite angles are equal, all right? So y is easily 113 degrees and x is 180 degrees minus 113. Remember, we said that angles on a straight line is 180 degrees. So simply we're going to subtract 113 from 118 from 180 degrees, giving us 67. And the reason is angles on a straight line. Now, once we've gotten x, we can very easily get y because they are opposite. They are vertically opposite angles. All right. So z is equal to 67 degrees. Reason that vertically opposite angles are equal. Now, we're asked to find also the value for x, y, and z in this diagram. Okay. Now, similarly, we are going to subtract 134 from 180 because angles on a straight line is 180 degrees. Now, when you do that, you're going to get 46. Okay. Now, if this is 134, this is a vertically opposite angle. Y is vertically opposite to 134. So, therefore, y is also 134 degrees. Now, same goes for z. We've gotten x as 46. We've gotten x as 46. And z is vertically opposite to x. So we can say that z is 46 also because vertically opposite angles are equal. Now, in this diagram, we're asked to find the value for x, r, and t. All right. Now, similarly, like what we did here, we're going to subtract 50 from 180 to get t. All right, because they are angles on a straight line. Now, when you do that, you're going to get 130. Now, when you get 130 as t, r is also going to be 130 because they are vertically opposite angles. And also, X is going to be 50 because they are vertically opposite angles. Now, number 4, we are asked to find the values for these alphabets. Okay, now I want you to pay close attention. Now, for P, to find the value of P, we are going to subtract 70 from 180. Reason being that this is an angle, these are angles on a straight line. Okay, if you look at it, there is a straight line here. Underneath 70 and P, we have a straight line. So the sum of angles on a straight line is 180 degrees. So we'll just subtract and we'll get 110. Now to get Q, like we've established, vertically opposite angles are equal. So Q is equal to 70. R is also equal to 110 because vertically opposite angles are equal. And S is also equal to 70 because corresponding angles are equal. If you look at this, you see a corresponding angle is formed here. Look very closely. These are corresponding angles. So S is equal to 70 because corresponding angles are equal. Now for T, you are going to subtract 70. We've gotten S at 70. We're going to subtract it from 180 because they are on a straight line. These are angles on a straight line. These two angles are on this straight line. So we can say that 180 minus 70 will give us 110 as our answer because the sum of angles on a straight line is 180 degrees. Now W is equal to 70 because vertically opposite angles are equal, and V is also equal to 110 because vertically opposite angles are equal. Now the B part asks us also to find the value for all these alphabets. Okay, now similarly we're going to subtract from 180 because angles on a straight line is 180. That's how we got our A here, and we're going to get B by subtracting 85 from 180 because there is also a straight line here. These two angles are on this straight line. Likewise, these two angles on this straight line. Now to get C, remember, we've established that the sum of co-interior angles are 180 degrees. Now, all these are co-interior angles. Okay, so we're looking to add 60 plus 85. We've gotten A as we've gotten our A as 60, and we've gotten this 85. So we'll add them together. When we get this, we don't have up to 180. So what we do is to subtract 145 from 180 to get the value of C. Alright, now when you do that, you are going to get 35 degrees as C. Now to cross check if your answer is correct, you just impute 35 into this and add with your 60 as A and 85. When you add it together, if you have 180 degrees, you are correct. So the reason is that co-interior angles are those supplementary angles that makes up 180 degrees. Now D is 60 degrees. This is our D. And the reason for that is that alternate angles are equal. These angles, angle A is alternate to angle D. Okay? And they are equal. So that's how we got our 60 here. And for E, we are going to also subtract 95, which is the value of our 95 is the value for B. We're going to subtract it from 180 to get 85 degrees because co-interior angles are those angles that adds up to get 180 degrees. Now the C part asks us to find value for Q. Simply we have to subtract 110 here from 180 to give us 70. Now the final number 5 is to also find the values for all these alphabets. Okay, now for A is equal to 50 because alternate angles are equal. Okay, A and this are alternate, so A is equal to 50. Now B is also 82 because these angles are alternate to each other, so B is equal to 82. Now to get C, we are going to use the principle of co-interior angles. Okay, co-interior angles sum up to 180 degrees. Since we have A and we have B, we're just going to sum it up and subtract the sum from 180 degrees to give us our C. Remember, if you want to cross-check, just impute the value you've gotten into your C and sum it up. If it gives you 180 degrees, you are correct. I hope you got that answer correctly. Now, the value for D is 48 because once we've gotten our C, you know that D and C are equal because they are vertically opposite angles. If you got that correct, please put your hands together for yourself. Now, 5B, we are asked to find also the values for these letters. All right. Now, to get A here, we'll use co-interior. We made use of the principle of co-interior angles. We said co-interior angles are those supplementary angles that add up to 180 degrees. So simply you add it. Okay, when you sum it, you get this equal to 180 degrees. All right. Then you collect like terms, simple mathematics. And when you do that, you subtract, get the value, then you divide into 2. Okay, now our final answer here is 31. To check if your answer is correct, okay, just put 30, substitute 31 into this value, multiply by 2, add to 1, and add the 2. If it gives you 180 degrees, you are correct. Now, for B, we also use corresponding angles are equal. All right, this is our B. These are corresponding angles, okay? These angles correspond. So, corresponding angles are equal. So, you know that 68 is equal to 3B plus 2. So, we have that here. Collect like terms, get our value, all right? And we divide. To get the value of B, we divide 3B over 3 equals to 66 over 3. And the final answer is 22 degrees. So, to check your answer, you can impute the value of B, 22, into this place to see if it will give you 68. Okay, because we said corresponding angles are equal. So when you impute the value, the answer you should get here is 68 degrees. Now for C, we don't need any calculation because we've established that vertically opposite angles are equal. All right, so we've gotten the value for C. Okay, students, we've come to the end of the lesson today. Today we learned quite a lot. We learned that when a transversal cuts between parallel lines, we have two sets of angle formed. We have the corresponding angle and we have alternate angle. And we also said that it is possible to get an alternate or corresponding angle when a transversal line cuts between a pair of non-parallel lines. Okay, now when a transversal cuts between a pair of non-parallel lines, we have alternate or corresponding angles, but the difference is that they are not equal. Okay, they are not equal. Thank you very much for listening. See you in my next class. Goodbye.